Okay, so we're on the final method of solving systems of equations, which is substitution. So we've gone over graphing, we've gone over elimination, and now we're finally on substitution. Once we get done learning substitution, we will use it for real life applications. So we'll be able to apply it to word problems and see its actual purpose. So substitution is when you substitute one for the other. Just like in our elimination, when we solved for x and then we used x to find out what y is, we were already using substitution. So we at least have some idea of what we're doing. So let's look at an example. This is example 1 on the first page of your notes. It says solve the system of equations algebraically. And notice that they're both equal to y. This would be perfect for graphing, but we're not going to solve it using graphing. We're going to solve it using algebra. So again, notice that they both equal y. They both equal the same thing. So in theory, they have to equal each other. Think about it like this. Think about that you have two babies, okay? It doesn't matter if they're born in the same hospital, it doesn't matter. But they're born the exact same day, same hour, same second, same everything. So what could you conclude? You could conclude that they were the exact same age. So when baby 1 is 1 year old, so is baby 2. I mean exactly the same time, right? And when baby 1 is 2 years old, 2 years old, so is baby 2, and so forth. And because at every point along the way, they are exactly the same age, you could also conclude that at every point along the way, baby 1's age is also equal to baby 2's age. Right? That makes sense. Because no matter what age they are, they're both exactly the same age. And that's really the concept that we're using here. They tell us that assuming, like let's just pretend that this is a baby and this is a baby, they're both y. They're both y years old at all times. Whatever y is, they're both that same thing. So at all times, they're both equal in age. So I could write another equation that said 2x equals x minus 3. Because if they both equal the same thing, they have to equal each other. There is no other way it could be. And once you set it up like this, it becomes very easy to solve. This is just a regular equation that you solve like we've been doing. So the x's will go away, and you'll get 1x equals negative 3, and therefore x equals negative 3. Now that you know what x is, you're going to use it to solve for y. Alright, I'm going to give myself some space, and I'm going to draw a line here. I'm going to use this equation because it seems the simplest, and so y equals 2 times x, but we already know what x is, so we're just going to plug it in. X equals negative 3. So 2 times negative 3 is negative 6, so y equals negative 6. And now we've solved for both of them. It wasn't that bad. This actually was a pretty simple equation, but system of equations. But still, the concept is there. When they both equal the same thing, they have to equal each other. So let's do some examples, and let's get some practice under our belt here. Okay, so we're going to do got it A and got it B. Go ahead and pause the video and do them by yourself first, and then you can fast forward the video or watch the video and see if you got them right. Always try to do it by yourself first, that way you can tell what you know and what you don't know. Alright, got it A, they're both equal to y, so therefore they must be equal to each other. So we're going to set it up as 2 equals x plus 4. Notice, all we're doing is setting them equal to each other. And then I subtract 4, and I get that x equals negative 2. Now that I know what x is, well actually I already know what y is too, because they told me what y is. So I already know. I already know what x and y is. I could have used that from the start anyway, which I did. Alright, got it B. I got 3x equals x minus 6. Now I'm going to subtract x from both sides, and these x's go away, and I get 2x equals negative 6. I'm going to divide by 2, and I get that x equals negative 3. I'm going to write it up here. So I know what x is. X is negative 3. Now I'm going to give myself some space, and I'm going to plug it back in. I'm going to use the second one because it looks simpler. I'm going to plug it back into this one. So I have y equals 3 times x. And I'm just going to go ahead and put negative 3 in for x. So I know that y equals negative 9. So there's my two solutions. X equals negative 3 and y equals negative 9. I have a cold and I'm having a hard time with my throat. But hopefully you have both of those right. If you have any questions, please raise your hand and I will answer any questions that you have. The next level of substitution is harder and it takes more practice, but you can get it. Alright, in this example, they're not both equal to y, but one of the equations is equal to y, so that actually helps us out. So one of the equations is solved for a variable. So we know that y equals 3x plus 8. So what we're going to do is in the next equation, where there was a y, we're going to leave some space. Because we could write y here, that's true, but we're not going to write y. We're going to write everything that was up here. Because we can either, again, don't forget, we can either use the y or we can use the 3x plus 8. Because if they're truly equal, we get to choose which one we use. Just like sugar and Splenda, remember? So if sugar and Splenda are truly exchangeable, then I can either choose to use Splenda or I can choose to use sugar. And if y is truly equal to 3x plus 8, I can either choose to use y or I can choose to use 3x plus 8. And I'm always trying to get down to one variable. Notice in the second equation, there's two variables. There's x and there's y. But when I rewrite it, and I don't choose the y, I choose to write 3x plus 8, notice now that there's only one variable, that I don't have any more y's left. I only have x's, which is exactly what I'm trying to do. I mean, every time I'm trying to get down to one variable, which has been our goal this whole time. And now that I've only got one variable, now I can actually solve it. Now it's just a regular, multi-step equation. Notice that I got to distribute the 4 to the 3x and the 8, and then I have to combine my terms, and then I have to solve just like normal. So I'm going to bring down the 8x because it's not going to change, and I'm going to distribute the 4. So 4 times 3x is 12x, and 4 times 8 is 32. And then I'm going to bring down the 12 because it didn't change. Notice the only thing that changed was when I distributed the 4. Everything else just came down the same way that it was before. And again, notice there's no y's. I'm not trying to solve for two variables here. I'm just trying to solve for one. When I rewrite this next time, I will be combining like terms. Notice I have an x, and a number. So I have two x's here. I have an 8x and I have a 12x. Well, 8 plus 12 is 20x. Plus 32 equals 12. And that's where I'm going to start from now. And now it's just a two-step equation. Now I'm going to solve this two-step equation. And hopefully by now we are really good at solving two-step equations. And we got 20x equals negative 20. And then we divide by 20. and we get that x is -1. And now that we know that x is -1, we're right back to where we were when we did elimination. Now we know one of the variables, and we're going to use it to solve for the second variable. I'm looking at the two equations. I think the first one is probably the easiest one to use. So I'm going to use this equation, and I'm going to plug x in for that. Okay, so I chose the first equation to use, and this is what I know, x is -1. And so I'm going to solve, and the only thing that I'm going to do is I'm going to put -1 in for x, and then whatever y is, that'll be the answer. So 3 times -1 is -3, plus 8 is 5, so y is 5, and x is -1. And we're done. You know, there's our two. We always have to solve for both variables. X is -1, y is +5. Is it easy? Not really. I mean, it's not impossible. It's a lot of work, but it's not hard. It's you know, it's medium. It's doable, and the more practice you get, the better you'll get at it. So I want to show you the textbook version of what we just did, which is exactly the same thing that we just did. So if you want to look at it maybe a little neater, a little more concise, pause the video and just look at it. But we've already done all this work, so I'm going to go to the next example. Alright, so we're going to do got it C and got it D. And I always want you to try them by yourself first, and then play the video. So pause the video, try C, and then play the video, and then try D, and then play the video. You know how it works. So the first thing I notice is that we're lucky because one of the equations is already solved for one of the variables. So we know that y equals 2x plus 1. And so what I'm going to do is, since y equals that, I'm going to put that in place of y here. So I'm going to rewrite the whole thing. I'm going to leave some space, because instead of writing the y here, I'm going to write the 2x plus 1. But make sure, this is a really important step, make sure that every time that you plug in like the 2x plus 1, that you put it in parentheses, because it needs to be distributed. Like that 4 has to be distributed. You can't just multiply it by the 2x. You have to distribute it to the 1 also. Alright, so now, again, notice that I only have one variable here, and that's an x. There's no y's left. Nobody can solve for two variables at once. No, nobody can. Not even Einstein. Like, that's why we eliminate one of them. That's why we substitute for one of them. You know, that's why we graph at the same time, so we can just look at it all at once. There is no other way to do it. So I'm just going to bring down the 3x, and I'm going to bring down the 26. Okay, and then we're going to distribute the 4. So I'm going to get 8x plus 4. And so now this is my new problem. And notice I have an x, and a number. So I have these two x's I can put together. Well, 3x and 8x is 11x. So I'm going to get 11x plus 4 equals 26. And now we're back down to a two-step equation, which is very simple, and we're just going to solve it. Okay, so I'm going to subtract 4. I'm going to get 11x equals 22. Let me draw my lines, cancels that. And I'm going to divide by 11. And I get that x is 2. So we're down to having one of the variables solved for. We know that x is 2. So let's go back and look at the original equations. Again, I think the first one's the easiest one. I'm going to use that one, and I'm going to plug 2 in for x in that one. So it was y equals 2x plus 1, and instead of x, I'm going to put a 2 there. And so y equals 4 plus 1, which is 5. So y is 5. And x is 2. So there's our solution. Our coordinate point would be 2, 5. Alright, let's try D. And again, notice that they've solved for y for us, so that's good. So y is 6x minus 4. So in place of this y, I'm going to put 6x minus 4. So 2x plus 5, and then I'm going to leave a space, equals 44. And in that space, I'm going to put 6x minus 4, and I'm going to make sure that I have the parentheses around that. And then I got 2x equals 44. And then I'm going to distribute. And 5 times 6x is 30x, and 5 times 4 is 20. And 5 times negative 4 is negative 20, if you want to think about it like that. And again, I have an x, and I have an x, and I have a number. And so when I combine like terms, I'm going to get 32x, minus 20 equals 44. And so that's going to be my equation that I'm now going to solve. Okay, so we're going to add 20 to both sides. These 20s go away, and I get 32x equals 64. I divide by 32, and I get that x is 2. So again, we've solved for one of the variables. I'm going to go back to the original, and it looks to me like the second one is probably the easiest one to plug it into, so I'm going to use the second equation to use. Alright, so instead of x, I'm going to put a 2. And 6 times 2 is 12, and 12 minus 4 is 8. So y is 8, and x was 2. So there's my solutions. So hopefully you got those right. What I want you to do now is I want you to do these 4 problems and raise your hand when you're done so that I can look at them and I can help you if you have any trouble. And always, always raise your hand if you have any questions. If you have watched all the videos and you have notes and you can answer questions then I can tell that you've watched the videos with the sound on, then I will answer any questions that you have always.